Find the side lengths in triangles ABC. So first we need to identify which side length we want to find first. It could be either line segment AB or line segment BC, and the order does not matter. So I will start with line segment AB. I will label that as X. And I'm going to label all of my sides as either opposite, hypotenuse, or adjacent side. And that all depends on my acute angle. As always in a right triangle, this is the star of our show. We are going to point to the opposite side of this acute angle and label this opposite. And then with the right angle, we'll point to the opposite side of the right angle and label this the hypotenuse, which is also the longest side length in a right triangle. And finally, we will label the side length that is next to the acute angle as our adjacent side. And now we're going to circle the information that we know, which is the hypotenuse, and the information that we need to know, which is the adjacent side. And here I'm going to write SO, KA, and TOA. And what we know is the hypotenuse H, and what we need to know is A. So we're looking at KA. And KA stands for cosine of some angle measurement theta is equal to adjacent over hypotenuse. And I'm going to plug in some information because we know that theta, the angle measure, is 20 degrees. We will set that equal to the adjacent side, which is x. We're trying to find it. It is now unknown. Divided by the hypotenuse, which is 14. And now we're going to put an invisible 1 underneath cosine of 20 degrees. And we are going to cross multiply. So we get that x is equal to 14 times cosine of 20. And we're going to plug this into the calculator. And I like to put the number in front of cosine of 20 because then I don't have to worry about closing my parentheses. So 14 times cosine of 20 gives me that x is equal to 13.156 units, since it didn't specify what units this was in. And I'm going to round it to the nearest tenth of a unit. So I have 13.2 units. And that's equal to x. So I'll make a note over here, draw an arrow here, line segment AB. Is really equal to 13.2 units. And then I can now find the opposite side by using either the Pythagorean theorem or by using another trig ratio. So let's practice another trig ratio. And this time I'm going to square what I know, which is still the hypotenuse. And now it's going to be what I need to know, which is the opposite side, and I'm going to label this as y. And I'll draw everything in red here so we can differentiate what's what. Right now I have O and H, so I'm going to use SO, which stands for sine of theta is equal to opposite over hypotenuse. And have sine of 20 degrees is equal to my opposite side, y, divided by my hypotenuse, which is 14. And again, we're going to put that invisible 1 underneath sine of 20. And we're going to cross multiply. And once we do that, we can see that y is equal to 14 times sine of 20. And if we put that into the calculator, you can do this with me right now. 14 times sine of 20, we end up getting approximately 4.8 units rounded to the nearest tenth. So y is equal to this. And I know that that represented line segment BC. That was 4.8 units.